Hello Year 5 and welcome to Week 6 Maths session for Tuesday for Green and Blue Group. We're going to begin today by having a look again at the multiplication questions where we're actually given three numbers to have to multiply together, and the idea that actually with the commutative law, meaning we can actually put those numbers in any order we wish and we will get the same answer. So just as a recap then, we explored yesterday looking at multiplying by 5, and we actually found that multiplying the 5 first with an even number was actually one of the easiest ways to do the whole calculation, as we didn't need to do as much partitioning here. Our second example then, we looked at multiplying by 10. We also explored, me personally, I feel like it's easier to multiply by 10 last, but you might have disagreed with me, which is absolutely fine. We all see maths in different ways, and that's something that should be celebrated. And multiplying with a 2 in the calculation, in the number sentence, again looking at actually doing that last so that we can just double the first calculation that's been multiplied together. Now I'd like to look at a third one here, which is 3 multiplied by 6 multiplied by 9. Now we're just going to explore 3 different ways we could have done that. So over here we've got 3 times 6 is 18, and then we would have done 18 times 9 is 162. Now we could have done 10 times 9 is 90 for our 18 times 9, and then 8 times 9 is 72 and added those together. Or if you know that 9 times 9 is 81, you could have doubled 81 as 18 is double of 9. So you might see the link there. Then we've got 3 times 9. 3 times 9 is not 162. I think what we mean there is that's the final answer. So 3 times 9 then there should have been 27. And then we took our 27 and multiplied it by 6. So we did 20 times 6 is 120, and 7 times 6 is 42. So added those together, which should have got us the answer, again, of 162. Let's put that in black there. Sorry about that, Year 5. There we go. And finally then, we've got 9 times 6, or 6 times 9 is 54. And then we've got 54 multiplied by 3. Now actually, what we're being asked there is 54, add 54, add 54. So actually, I was able to use my knowledge of partitioning to think, well, 50, 50 and 50 makes 150. And 4 add 4 add 4 is 12. So 150, put that down there, add 12 is equal to 162. And actually, we might find that that's possibly the easiest one to do. Maybe if we're quite good with our understanding of this doubling here, that would have worked, maybe the quickest. But actually for me, I found this way and leaving timesing by 3 last the easiest, because often it's quite easy to add 3 numbers together like it was in this calculation here. So if it was my choice, I would probably go for this one here, suggesting then that we leave multiplying by 3 to the end. So like yesterday then, there's some different calculations here for you. I'd like you to have a little look at them, decide which order you're going to have a go at calculating them in, what works best. You might find you're going to spend time finding more than one way and maybe evaluating which way you think is the best. That's absolutely fine to explore. So if you'd like to pause the video now. And again, these are just my chosen ways of ordering the numbers. So you can see I tend to like to leave my timesing by 10, timesing by 2 till the end, and multiplying by 5. You can see how I decided I'd multiply by 4 to make 20, as I thought 20 times 8 was probably the easiest way to go. And more importantly, now we've brought in this idea of timesing by 3 at the end, I found that easier because I did 8 times 4, which is 32, and then 32 times 3. So I thought, well, 30, 30 and 30 is 90, and 2 and 2 and 2 is 6. So that would give us the answer of 96. So you can have a little look at those now. So our main session for today then, we're going to be applying our knowledge of adding and subtracting fractions with different denominators to some different problems that we will explore, and these problems do change as you work through the different tasks. It's just really important today to read the questions carefully. So in order to be successful, we might find bar models are useful to help represent those problems and the fractions, really being clear on the value of the denominator and the numerator in these fractions, and using knowledge of factors and multiples, that's our times table understanding, to help find equivalent fractions. So I want you to think about this now. You might like to make some notes, you might like to talk to somebody at home about this, or you might just want to have a think in your head. If we were to imagine an alien landed on our planet right now and they wanted to find out how to add and subtract fractions, and they knew nothing about it, and add and subtract fractions, importantly, with different denominators, what could we say? What should we say? What would our instructions be? So pause the video now and have a little think. Okay, so probably the first thing we're going to need to teach our alien is about equivalent fractions. So a little bit of a recap now. If we've got 2/6 and we are trying to turn our 2/6 into 18ths, we're thinking about how many lots of 6 make 18. And it's 3 times 6 that makes 18. Therefore, if we've multiplied 6 by 3, we also need to multiply our numerator, our 2 by 3. So 2 times 3 equals 6. So what we can then see there is actually 2/6 is equal to 6/18. So finding equivalent fractions is really important. So let's explore the same one from yesterday. 3/9 plus 1/3. We're going to need to find an equivalent fraction for our 1/3. We're thinking about, how do we go from 3 to 9? What do we multiply by? We multiply by 3. So we also need to multiply our numerator by 3, which gives us the answer of 3/9. Now that our denominators are the same, we can add them together. 3/9 add 3/9 is 6/9. So very clearly then, find that equivalent fraction. So another example here, 2 24ths add 1/6. We need to change our 1/6 into 24s. 6 times 4 is 24, so 1 times 4 is 4. So we get the answer of 4 24ths. Now our fractions have the same denominator. We can add them together. 2 24ths add 4 24ths equals 6 24ths. So find the equivalent fraction and then add the fractions together. And when we say add the fractions together, obviously the fraction from the original question and then our one that we found the equivalent for with the same denominator. And subtracting then, 9/16, subtract 2 quarters. We're going to turn our 2 quarters into 16th. 4 times 4 is 16, therefore 2 times 4 is 8. So our equivalent fraction of 8/16 here, we can now subtract from our 9/16, which gives us 1/16. Let's have a look at how we're going to apply that to the problem today then. Anna and Ella are sharing a pizza. If Anna eats 4/18 of the pizza and Ella eats 2/6 of the pizza, how much do they eat all together? So what we're looking at here is we are looking at adding Anna's amount and Ella's amount. So we're looking at 4/18 add 2/6. Now the first problem we've got is that the denominators are not the same. So we need to find an equivalent fraction for 2/6 where the denominator is 18ths. 6 times 3 is 18, so 2 times 3 is 6. Now we have our equivalent fraction of 6/18. We can do 4/18 add 6/18 is obviously equal to 10/18. And if you've been looking for a slightly harder challenge this week, then you may have looked at how can you simplify your fraction. So maybe looking at a number that will divide into both of these and so you might have had the answer of 5/9. Don't worry if you didn't, and don't worry if that seems a little bit too tricky, but for some of you, you might want that challenge to simplify the fraction as well. So we know that altogether they had 10/18 of the pizza, or 5/9. Are we able to work out how much was left? Well, if I think about that bar again, and you could draw a bar to help you with this, if I had a bar of 18 and I've shaded in 10 that I've eaten, that means there must have been 8 left over, so 8/18. You also obviously may have had there 4/9 was how much was left over. So you're going to be applying your knowledge of adding and subtracting fractions with different denominators today to a range of different problems. We look forward to seeing how you get on. Thank you.